What are gravitational waves? What causes them? How do we detect them? And why should we care? If you've been following along with the series, then you know that space is full of gravitational fields. Anything with mass has a gravitational field. And if that object is accelerating, its gravitational field changes. This change in the field can propagate outward at the speed of light in the form of a gravitational wave. Think of it like dropping a pebble into a pond. The pond is the fabric of space-time. The pebble is a mass. When the pebble is at rest, the pond is flat. But when the pebble is dropped, it causes ripples that travel outward. Gravitational waves are similar. They are ripples in the fabric of space-time that carry energy away from where they were created. However, unlike the ripples in a pond, which die out after a while, gravitational waves can travel for millions of years before they dissipate. And just like ripples in a pond, gravitational waves carry energy. However, the amount of energy they carry is extremely small. So small, in fact, that we can't feel them, even though we are surrounded by gravitational waves all the time. The first gravitational waves were detected in 2015 by the LIGO and Virgo collaborations. They were produced by a pair of merging black holes. Since then, we have detected many gravitational waves from merging black holes and neutron stars. But why do we care? Why is it important that we detect gravitational waves? Well, for one thing, it's just plain cool. We are literally detecting ripples in space-time itself. But more importantly, gravitational waves give us a new way to observe the universe. For example, we can use them to study the inside of black holes and neutron stars. We can also use them to test our theories about gravity and the early universe. For example, one of the predictions of Einstein's general theory of relativity is that gravitational waves should exist. We have confirmed this prediction by detecting gravitational waves. But we can also use gravitational waves to test alternative theories of gravity. In the future, gravitational wave detectors will become more sensitive, and we will be able to use them to study a wider range of phenomena, such as the formation of supermassive black holes. In short, gravitational waves are one of the most exciting areas of research in physics today, and we have only begun to scratch the surface of their potential. So what are gravitational waves? They are ripples in space-time that carry energy away from where they were created. What causes them? Any accelerated mass will create gravitational waves. How do we detect them? With special instruments called interferometers. Why should we care? Because gravitational waves give us a new way to observe the universe, and they allow us to test our theories about gravity and the early universe. What do you think about gravitational waves? Let us know in the comments. And if you want more stories that explain the world around you, make sure you subscribe.